Hello, my name is Nicholas Terhar, and in this video I'm going to be going over my physics problem that I solved. So the problem is a block M1 with mass of 3 kilograms sits on a horizontal table and is connected by a massless string over a frictionless pulley to a hanging block M2 with a mass of 2 kilograms. The coefficient of kinetic friction between M1 and the table is 0.2. Find the acceleration of the blocks. And here's a diagram of that. So we have block M1 on the table and block M2 hanging. And then first thing we do is draw a free body diagram for M1 and M2. So M1 has normal and gravitational, and in the y-axis, and on the x-axis it has tension from the rope and kinetic friction from the table. And block M2 only has in the y tension and weight. And then from those, we get our second law equations, which we use for M1. We have some of the forces in the x equals tension minus kinetic equals mass of 1 times acceleration of 1. And then for block 2, we have some of the, we also have the y for block 1. We have some of the forces in the y equals normal minus mg equals 0. And then for block 2, we have some of the forces in the y equals tension minus mass of 2 times gravity equals mass of 2 times acceleration. And then from there, we rearrange the equations to solve for tension. And then we set those equations equal to each other, and we get that equation. And from this equation, we have the acceleration 1 and acceleration 2. So our next step is to relate these two accelerations. So acceleration 2 equals the negative of acceleration 1. And then we plug that into what we have, to what we had, and then we solve for A1. So to solve for A1, we bring both of the A1s over together on one side, and then we factor that A1 out, and then we divide the other side, both sides, by M1 plus M2. And here, our only issue for plugging in values is now the force of kinetic friction, and so we have to solve for that. And so kinetic friction equals normal times mu. And so we go all the way back to our Newton's second law equations. We have some of the forces in the y equals normal minus mass gravity equals 0. So normal equals m1 gravity. So force of kinetic equals mass of 1 gravity mu. And then we plug that into our equation from last slide. So the top one is the equation from the last slide where we ended up, and the bottom one is the equation with that plugged in. And from there, we can find our answer by simply plugging in the values into that equation. So we get A1 equals 2 times 9.8 minus 3 times 9.8 times 0.2, and all of that divided by 3 plus 2, and we get 2.7. And that does make sense because 2.7 meters per second squared is less than 9.81, which is the gravitational constant. So if there was nothing holding that system down, both blocks would be traveling at 9.8 meters per second. But since we have some kinetic friction, that is holding it back. So our answer should be less than 9.81, which it is.